Number 21, given an array with n greater than 3 elements, we can apply one swap operation on arbitrary 2 elements. What is the minimum number of inversions? Or maximum, yeah, correct, maximum number of inversions that can be reduced by one swap operation. Okay, yeah, one swap. Yeah. First, you need to get an idea. All right, so maximum number of inversions. So we just swap 2 of them. All right. First, this one is very hard. Yeah, this one is very hard. First, you need to consider locations of these 2 elements to be swapped. Okay, locations. Think about if the locations matter or not. The locations related to the maximum number or not. Think about that. Yes. Let me draw this array. Okay, array. Yeah. Array. So all the elements we distribute along this array. Okay, all right. Now I pick 2 of the elements I want to do swap operation. Okay. A sub I and A sub j. We do swap operation. Okay. Now let's consider the impact of the swap operation in our counting number of inversions. When we count number of inversions, the swap operation make any change to the count number. When we count number of inversions, this will make any change. Think about that question. All right. Yeah. These 2 elements divide the whole array into 3 line segments, right? 3 parts. Part 1, okay? Yeah. Part 2 and part 3. Okay, all right. So when you do swap operation, look at so here, when you consider one inversion, look at your, so here, inversion. So now we consider inversion. Okay. For the number of inversion, we need to consider 2 elements, right? 2 elements, okay? Yeah. So inversion A to the X, A sub X and A sub Y. How about that? A sub X, A sub Y. Look at if they form inversion. Okay, all right. Think about if A sub X is here, A sub Y is there. When we do swap between AI, AJ, does it impact this inversion? No, right? Doesn't matter, right? Doesn't matter, right? Think about, so when A sub X in region 1, A sub Y in region 3, before that swap, after that swap, this pair, if it is an inversion or not, the answer is the same, right? Yeah, when we do this swap operation, we do not change the counting on this pair, right? Inversion counting on this pair. We do not change that counting, okay? that means no impact, right? When we do swap, that means no impact, okay? Yeah. Elements at the left-hand side, at the right-hand side, right? Think about that, okay? All right. Then elements, think about in different portions, elements in different portions. Which one you may have impact? Think about that. Which one you may have impact? When only when AX or AY is one of AI or AJ, right? Yeah. Only when you touch it, then you have impact, right? If you do not touch it, you have no impact, right? Think about that. Okay. Yeah. So that's one thing. Yeah. All right. Another thing. All right. So here, this tells us when you count inversion. Yeah. Oh, yeah. Here we count inversion change. All right. Because our goal. So here we count inversion change. Or to right. Count the inversion change. You only inversion change. If no change, we ignore it. If no change, we ignore it. Okay. Inversion change, you only consider the pairs A. Too bad. Why so slow? A sub I A A sub X or right. A sub J for the inversion change, you only consider these two types, right? Yeah. These two types. Okay. Yeah. All right. Now look at this one. I only need to do analysis on this one. For AX. All right. So AS, you need to consider three regions, right? Region 1, region 2, region 3. AX sub X comes from three different positions, different types of positions. Okay. Yeah. Where AX comes from region 1, is there any change before swap, after swap? No change, right? When AX comes from region 2, is there any change before swap, after swap? Region 2. Region 2. Before change, after. Yeah, could be changed. All right, region 2. How about region 3? when AX comes from region 3, any change? Any change before swap? Region 3. Region 3. Inversion, no change, right? So you can see region 1, no change. Region 3, no change. Only region 2, you have the change. So this analysis tells you what conclusion you can get. This analysis. What conclusion you can get? We want to get a maximum number of inversions, right? Yeah, we want to get maximum. Maximum, we want to make the change as big as possible, right? That means we should compress region 1, region 3. How about that? We should compress region 1, region 3. That means we should enlarge region 2 as big as possible. Region 2 as big as possible. Okay? Yeah. How to make region 2 the maximum? Region 2 maximum. That means the whole line segment, except the first one, last one, all the other elements belong to region 2. No region 1, no region 3. That's the largest possible region 2. Okay, we can make the change the biggest. All right, now you consider this case. Swap first element, last element to get the maximum number of inversions. First and the last to get a maximum inversions. Now you're halfway there. You only consider first and the last. Swap to get the biggest change, inversion change.
Is inversion that like two elements are out of order?
Yes.
Okay.
Yeah. Out of order.
That's globally, not just.
Globally. Yeah. Globally.
Just not, not globally.
Yes. Globally. Yeah. Yeah. Globally. Globally.
The maximum number of elements out of order globally is.
Yeah. Yeah. Now, yeah, only consider, yeah. Oh, yeah, this way. You use n consecutive numbers. Okay. You use n consecutive numbers, 1, 2, 3, through n. For that n, you can choose some certain numbers. Okay. Try to figure out the first one, last one, swap. Okay. Yeah. And try to guess the formula. Make a guess. Okay. You can apply guess and verify. How about that? Guess some formula, then verify. Use some more examples to verify it.
So basically, you get more inversions when you don't swap it with a.
Do you want, yeah. Do you want me to give you a little more information? Yeah, like this. Okay. All right. All right. How about let's use simple examples. 1, 2, 3. How about that?
Okay.
Yeah. 1, 2, 3. Before swap. Okay. Then we do swap. We swap 1 and 3. Okay. 3, 2, 1. Right. All right, now you count the number of inversions change. They change. All right, yeah. Before swap, how many inversions do you have? 0. Yeah, 0. No inversions. All pairs are in order. Okay, yeah. After inversions, how many? After swap, how many inversions?
I think that you have to, so it's the global ones for each of them, right? So 3 is out of order, 1 and 2, because it's at the front and it's last.
Right.
So it's how many other elements And so it's 2 for each of them. So
All right, let's count in this way. All right. Let's pick the first one, 3 element. 3, 2, is it inversion? 3, 2,
yes, the
Yes.
local inversion.
yeah. 3, 1, inversion.
Yes, it's global.
Number 2, yeah, global, yeah, whatever. 2, 1, inversion. Yeah, that's 3. That's all we have, right? No more.
Oh, we only count them once.
Yeah, only count
Okay.
once. Yeah. Only count once. Each pair only count once. 3. The
Fine.
change 3. Yeah,
Fine.
that's what n equals 3. Then you can try n equals 4 equals 5. Yeah. And see, try to figure out certain formula. Okay. Try to guess. Formula related to n in terms of n. Yeah. Yeah, we don't know. We need to guess by our experiments. We make a guess. Okay. We have experiment here. So we make that guess. Yeah. So then after you guess that formula, use that one to verify a few more examples. Okay. And make sure your guess is correct. Okay. Yeah. Yeah. Try this way. All right. Yeah. Yeah. Okay. Yeah. All right.
Okay.
Another question. Yeah, here we already passed but another question, then we take a break. How about that?